Greetings to you all. We're looking at another technique of integration, which is when we have fractions. So look at integration of fractions. Now, most often when we have fractions to integrate, let's start by looking at this. When we differentiate ln x, what do we have? We have 1 over x here, provided x is greater than 0. Okay, now we know that the derivative of ln x is 1 over x, means the integral of ln x of 1 over x should give us ln x. This means the integral of 1 over x dx will give us ln absolute value of s plus c. That's what the integral of 1 over x. So in conclusion, the integral of 1 over ax plus b dx will give us 1 over a ln ax plus b plus our constant c. Right? If we want to look at examples, how do you apply this? Let's look at some examples. The integral of 1 x plus 3 dx is, it will be ln, our a here is 1. If we want to use the general rule prescribed, our a is 1 over 1 there, then ln absolute value x plus 3 plus c, the constant of integration, because the limits are not given. Right, the limits are not given. Now, if you have 4x plus 5 dx, our a here is 4. So we have 1 over 4 ln 4x plus 5 plus our constant k, the constant of integration. So each time that we are doing this integral, when we look at it critically, if the numerator is a derivative, if you have a fraction like this to integrate where the numerator is a derivative of the denominator, what do you have? You have ln f of x plus our c, that's a numerator, is a derivative of the denominator. You go straight to ln f of x plus c. For example, if you have the integral of 2x plus 6, all that divided by x squared plus 6x dx with respect to x, when you look at the numerator, you see when you differentiate x squared plus 6x, it gives you 2x plus 6. So the answer to our integral is simply ln x squared plus 6x plus our constant of integration. Alright. Now let's look at another example. The integral 2x minus 3 with respect to x. let's look at this. When you differentiate this is a fraction. When you differentiate the numerator, the denominator, you have 2, but at the numerator it is 1. How can I express this 1 in terms of 2? This same integration can be written as half all that 2 here, 2x minus 3 dx. You see, half here, if you have to cancel, this 2 will cancel here, right? This will cancel here, you will still be left with 1 over 2x minus 3. But we are not cancelling, so we have written it in this other form. So you now see that the derivative 2x minus 3 when differentiated will give us 2. And with our half, so our answer will be half ln 2x minus 3 plus c, very important, plus c. Now we have other fractions that we can be asked to integrate. If you are asked to integrate this fraction, for example, x plus 3 divided by x plus 2 with respect to x, okay? Most often what we use is the fact that we always verify what we have seen in the previous examples is that we verify if the numerator is the derivative of the denominator, then we apply ln. Now this one, in this case, if you look at this fraction, the degree of the numerator is the same as the degree. That's degree 1 here. When you have this nature, you express it as a fraction with other parts, either using long division or using other tricks. Now, if I want to use long division, I will say s plus 3 I divide by x plus 2. Now, how do you divide? How do you look for the x divided by x is 1. You have 1 times x is x here. 1 times 2 is 2 here. S minus x 0. 3 minus 2 1. Okay. Which means I have written this polynomial. This fraction. Can be written now as the answer is 1, and our remainder here 1 x plus 2. With that, I can be able to integrate. To integrate this function, I will integrate by this one. Okay. Or since the powers, the degree of the numerators is the same to that of the denominator, this is what I can do. X plus 3 can be written as, in terms of this denominator, as x plus 2 plus 1 over x plus 2. Now when you do that, you have x plus 2 divided by x plus 2 plus 1 divided by x plus 2. You see it dividing, and here it gives us 1 plus that same answer, x 1 over x plus 2. Okay. So that said, when that is obtained, it means the integral of x plus 3 over x plus 2 dx will simply be the integral 1 plus 1 over x plus 2 dx, which when we integrate each of them, when we integrate 1, it gives us x. When we integrate 1 over x plus 2, it gives us ln x plus 2 plus c. That's how you obtain the answer to that integral. We equally have other fractions again that when asked to integrate, you need to express into partial fractions. You need to express it into partial fractions. For example, we are asked to integrate 2, 4, 6x plus 1 over 2x minus 3 into 3x minus 2. Now you should carry out this integration. To carry out this integration, the first thing is to express the integrand into partial fractions. Express it into partial fractions. Okay, that we are expressing 6x plus 1 over 2x minus 3 into 3s minus 2 as a partial. Means that we write it as, instead in the degree of numerator less than denominator. So write it here as a over 2s minus 3 plus b over 3x minus 2. Right? We're going to express this into partial fractions, either using cover up or expanding. Okay, when we multiply through the expression, we arrive at 6s plus 1, giving us a into 3x minus 2 plus b into 2x minus 3, which when rearranged, we have 3a plus 2b into x, negative 2a minus 3b. So, looking at the coefficient, it means here we have 3a plus 2b is equal to 6, negative 2a minus 3b is equal to 1. Right? When we solve this simultaneously using a method of our choice, a will give us 4 and b will give us negative 3. So we are now able to write it as a partial fraction. We are now able to write the integral as a partial fraction.